We're surrounded by smart devices, right? Your watch, your thermostat, maybe even your coffee maker. But have you ever really stopped to think about how they all connect and, well, work together? Today, we're going to pull back the curtain and demystify the blueprint that makes it all possible: IoT architecture. So let's just start with a number that is kind of hard to wrap your head around. A Gartner report predicted that by 2020, there would be 20.4 billion IoT devices out there in the world. That is nearly 3 times the entire population of Earth, all connected, all chattering away to each other. The scale is just staggering. So how do we make sense of a network that massive? Well, we're going to do the opposite of thinking big. We're going to zoom way, way in and focus on just one example: a smart farm. We're going to follow the journey of a single piece of data, literally from a drop of water in the soil all the way to a decision up in the cloud. It's the perfect way to make these huge abstract ideas feel real. Okay, so here's our game plan. We'll kick things off with the basic anatomy of an IoT system. Then we'll trace that single drop of data on its journey. After that, we'll zoom back out and see how the same blueprint is used everywhere, from your house to a massive factory. And finally, we'll look at the big challenges that architects face when they're building our connected future. All right, let's dive in. First up, we need to break down the fundamental building blocks. What exactly is an IoT system even made of? At its heart, the Internet of Things is pretty much exactly what it sounds like. It's a network of physical things, anything from a tiny smartwatch to a giant tractor, that are given digital senses and the ability to communicate over the Internet. And IoT architecture? Think of it as the rulebook. It's the technical blueprint that lays out exactly how all these different devices, gateways, and cloud platforms are supposed to talk to each other. Without it, you just have a bunch of noisy, isolated gadgets that can't work together. To make this even clearer, let's use an analogy that I think works perfectly. Imagine a complete IoT system as a biological nervous system. It has senses to perceive the world, a network of nerves to send signals, and a brain to process it all and decide what to do. So layer 1 is the senses. This is what we call the device or sensing layer. It's made up of sensors that collect data from the physical world, and also actuators that can perform actions, kind of like how our eyes see and our hands can move to interact with things. And these digital sensors can measure almost anything you can think of. On our smart farm, that soil moisture sensor is absolutely key. But in other systems, you'll find everything from GPS and motion sensors to light sensors and accelerometers. The variety is just enormous. Okay, so we've got our senses collecting all this data, but how does that data actually get to the brain? Well, that's where layer 2 comes in, the network layer. It's like our spinal cord, carrying signals from our fingertips to our brain. This layer uses technologies like Wi-Fi, Bluetooth, or cellular networks to transmit data from the sensors onward. And finally, layer 3 is the brain. This is the data processing and application layer. This is where all that information ends up, usually in massive cloud platforms and data centers. They receive the information, analyze it, and turn that raw data into an intelligent action, like telling the farm's irrigation system, hey, it's time to turn on. So we know the what. Now let's get into the how. We're going to follow that single data reading from our smart farm soil moisture sensor and really see this architecture in action, step by step. It all happens in 4 key stages. First, the sensor collects the raw analog data. Second, a gateway device nearby gathers that data and digitizes it. Third, something called an edge computing system might pre-process it for a really quick, immediate insight. And fourth, it gets sent up to the cloud for the deep analysis, where it can be combined with other info like weather forecasts and historical data to make a truly smart decision. Now, this diagram might look a little complex, but it shows something really, really important. This is a real-world example of a global standard called 1M2M. You can think of it like a universal translator for IoT devices. It defines the rules so that a smart light bulb from one company can talk to a smart thermostat from a totally different company. This interoperability is what makes the whole IoT ecosystem actually work. Okay, so why does understanding this one smart farm example matter so much? What's the so what here? Well, it's because the exact same blueprint, the same fundamental architecture, powers nearly every IoT system you can think of. And this is what's so brilliant about a strong architecture. The system that decides when to water a field is, fundamentally, the same one that manages your smart home, automates a factory floor, helps balance a city's power grid, or tracks a valuable shipment across the entire globe. But, and this is a big but, building this connected future is not easy. For all of its power, this architecture comes with a really complex set of trade-offs and challenges that someone has to figure out. On the one hand, you get these incredible benefits like efficiency and being able to predict problems before they happen. But on the other hand, every single connected device is a potential security risk. There are high costs to get started, and the whole system depends on having a reliable network connection. It's a constant balancing act. And that's where a very specific person comes in, the IoT solutions architect. Their job is to navigate all these challenges. They're the bridge between a business goal like we want to save water and the incredibly complex technical reality. They're the ones making the tough trade-offs to build a system that's secure, scalable, and actually works. And all of this leaves us with a final big picture thought. What we're really doing here is building a planetary scale nervous system with trillions of tiny digital nerve endings all sensing the world in real time. So the question we have to start asking ourselves is, what kind of collective intelligence are we actually creating with all of this?